Okay, let's begin. Question 4. Harun and Kuna competed in a 200-meter race. Harun ran at a constant speed of 5 meters per second. Kuna ran at a constant speed of 8 meters per second. Find the time taken by Kuna to reach the finishing line. Of course, you need to use your formula. Sky, tell me your formula. Equals to? Okay, so you have distance divided by speed, you get time. So this is the formula. Okay, I want to find time. Distance over speed. What is the distance, Shirley? 200 meter, right? Okay, because the entire race is 200 meter. Divided by what's the speed? 5 meters per second. Caroline, what's the answer? No. Colin Chi, what's the answer? Why are you spoiling the thing? Why are you spoiling the thing? I'm supposed to trick Colin Chi, right? I'm supposed to trick Colin Chi, right? Actually, he was tricked. He wanted to answer already. It's all yours. What's the answer? Colin Chi? You sure? 12.5 or 25? 25 what? Okay, so part A is 25 seconds are quite easily done. The group of boys there better shut up before you end up copying this question. Okay, question B. How far was Harun and Kuna from Kuna when Kuna reached the finishing line? Of course, Kuna, since he ran faster, right? He's going to reach the finishing line first. But how far was that? Okay, very simple. Let's think of it in another way. I have two persons running a race. Okay, this is the race. They are both starting at the same time. Kuna and Harun, right? Kuna's speed is how much? 8 meters per second. And Harun is 5 meters per second. They are both supposed to complete this race. And this is the finishing line. This here is the finishing line. Okay? Will Kuna or Harun reach the finishing line first, Kaden? You didn't hear? Why? Was I too soft? Let's double check. If Alexis can hear, that means I'm loud enough. Alexis, answer the question. Oh, sorry. 10 times. Okay. So the question is, who will reach the finishing line first? Okay, of course, Kuna will reach the finishing line first, right? And then Harun will be behind because since Harun is running at a slower speed, am I right or wrong? Yeah. Okay, so Harun will continue running. Okay, the question was asking, how far was Harun from Kuna? Right? That means I want to find the distance from here to here, right? Yes or no? Actually, the question is very simple. Now, two persons running at the same time, one is 8 meters per second, the other one is 5 meters per second. After 1 second, how far apart are they, Jing Kai? 3 meters. Do you all agree with him? Both of them running at the same time, right? One is 8 meters per second, the other one is 5 meters per second. After 1 second, the distance between them will be how many meters? 3 meters. Very good. So, Kuna ran for how many seconds? 25, right? But in 1 second, the difference will be 3 meters, right? Correct? So, what is the difference between the two guys when Kuna reached the finishing line? Ernest? 75 meters. So very simple. How we get the answer is actually 8 meters per second minus 5 meters per second. I know it's 3 meters per second. So the difference in the speed multiplied by the time will give you the total distance, right? Sorry? For the second one, is it this? Yes, you should. Okay. So since you are finding the distance, distance equals to speed multiplied by time. Okay. Understand what am I trying to explain to you? Okay. Rather than also another way you can do it is, I think it's slightly tougher, is you find the distance ran by Harun in 25 seconds. Correct? You can find the distance ran by Harun in 25 seconds, right? So what's the distance ran by Harun in 25 seconds, Bjorn? You don't need a calculator. 125. Please be at the right question, okay, when I'm talking. So do you all agree it's 125 meters? So you know that both of them ran for 25 seconds. Harun will have ran 125 meters. Whereas Kuna will have ran 200 meters. The difference is 75 meters. That's another way of doing it. Okay? So I'm showing you the two different ways of doing. Let's look at the next question, please. I have two towns that's actually 980 kilometers apart, X and Y. So I have X and I have Y. And they are actually 980 km apart. At 8 a.m., K traveled from X to Y. So I have K. And this is at 8 a.m. And while Jolene traveled from Y to X. So at the same time, I have Jolene traveling from Y to X. This is also at 8 a.m. Okay? Right? Both of them did not change their speed throughout. That means they are traveling at a constant speed. Okay? Uniform speed throughout. Okay? Jolene's speed was 75 km per hour. Okay? Find the distance K travel when they met at 3 p.m. Okay? They met at 3 p.m. So I don't know where they met, but assuming they met, I don't know who's traveling faster. So of course there's a few possibilities. I can draw K here and Jolene here, or K here, Jolene here, right? There's multiple space. Let's since we don't know, I'll just draw it somewhere around here. So they met somewhere around here. And this is at 3 p.m. So far so good? Right. So now, can we know the distance traveled by Jolene? We can, right? Because from 8 a.m. to 3 p.m., how many hours is that, Kaden? 7 hours. Do you agree? So let's look at some of the information I have. Distance, speed, and time. I know that the time is 7 hours. The speed is 75 km per hour. Will I be able to find the distance traveled by Jolene? Yeah. I can, right? So since I can find the distance traveled by Jolene, let's find the distance traveled by Jolene. What's the formula, Jack? So speed of Jolene times time taken by Jolene. So speed of Jolene is 75 km per hour and the time taken is 7 hours. So what's the distance traveled, Jack? $525 what? Kilometer. Yes? They took the same time. Yeah, okay, we can write TJ is fine, it's not fine. Okay? Yeah, we write TJ, J for Jolene. Okay, let's look at the other part. So I have distance, speed and time for this part of the, of course, time is also 7 hours. Speed is what we need to find, right? But before that, can we find a distance for covered by K? Yes. I can write 980 km minus 525 km. Oh, we are supposed to just find a distance, is it? Yeah. Okay, so what's the distance? 400 and? Sorry? It's more of like a way for to help you organize your information. Preferably, yes. Okay, so if you need to find the speed for K, you can find it, right? After finding the distance. We can, right? So, Jing Kai, how do I find the speed for K? And then, what's the answer, Colin? Oh. $65. Do you all verify his answer? Yes. Okay, so that's how we find the other part of the question if they do ask. So for this part, they only need to find 455 km. Okay, next question. Okay, now I have Ahmad and Nansing running at constant speed from the same point in opposite direction. So I have this. I have Ahmad and the other boy is called Nansing. They are running in opposite direction. They are starting from the same point. Okay. After running for 10 minutes, they were 5,400 meters apart. So Nansing may be here, and then Ahmad may be here. So the distance between them, like what the question states, is that they are 5,400 meters apart, right? You all agree? Yeah. So that's what's happening. Ahmad ran at a speed of 240 meters per minute. Okay, you are supposed to find Nansing speed. So this is actually 240 meters per minute. So we know that for Ahmad, the speed is actually 240. Do we know the time? How long did Ahmad run? 10 minutes, right? Can I find the distance ran by Ahmad? Yeah. So distance ran by Ahmad is actually, what's the formula? Speed times time. Okay, so speed is 240 meters per minute multiplied by time, 10 minutes. So what's the total distance covered, Vikram? 2,400 what? Meters. So I know that from this part to this part of the journey is 2,400 meters, right? Yes or no? Okay. Will I be able to find the distance covered by Nansing? Yes. So distance covered by Nansing will be 5,400 meters minus 2,400 meters, which is 3,000 meters. Can I find the speed for Nansing? Yes. Okay, what's the speed for Nansing, Lauren? Which is? Okay, so distance divided by time taken by Nansing, which is 3,000 meters divided by 10 minutes, right? Correct, which is 300 meters per minute. So quite easily done. Right. I'm going to move on to the next question. Anyone has any problem so far? Can cope? Okay, let's look at the review. An aeroplane traveled at a speed of 885 km per hour. Find the distance it covered after 7.5 hours. Ernest, tell me the formula. Distance equals to? What's the speed, Terence? And the time? Okay, Aisha, tell me what's the answer. 6,600? 0.5 what? Kilometers. Okay, so please write down the answer. 6637.5. 6637.5 kilometers. Please get the units correct. Yes, what's the question? Let's go. Next, yes, Bjorn. No, miles is an American term. Okay, British, we are using kilometers. We will not be using miles. You will not be covering it. So let's not confuse each other. Okay? Okay, question 2. You got something to say? You can say it out now. You say finish, then I continue, can? You got something to say? Okay, question 2. Sorry? Yeah, you're supposed to keep it. Ask Leroy how much you are supposed to finish. Okay. Question 2. A ferry began its journey at 8 a.m. in the morning and traveled 208 kilometers towards its destination. The average speed of the ferry was 32 km per hour. What time did the ferry reach its destination? Bjorn, tell me how to do. What's the distance? What's the speed? What's the answer? Danish. 6 what? 6.5 hours, 6.5 hours is fine. What? What's the total distance here? What's the total distance, Colin Chi? If it traveled 208 km, isn't it the total distance it traveled? So is that the total distance? What do you mean in a way yes? Either is a yes, no. Don't tell me in a way yes. So is that the total distance it traveled? Yes. Then tell me what's the total time it traveled? You understand why is that a total time or not? At first I thought Bjorn will be the only one that's confused. That's why I asked him. In the end, you're the one that's confused. Oh, okay. They asked you what time is it? So what time did he reach his destination? Okay, so you need to draw a timeline. Okay, so 0800, 6 hours later, plus 6 hour, it will be 1400, plus half hour, 1430. Okay, please leave in 24-hour clock since the question gave us in 24 hour. 1430. Okay? Anyone has any problem? Can I move on?
Nope.
So this question, question 3. A duck swam from one end of the pond to another end and back again. So you have a big pond here. So there's this duck. Swim here, reach here, then swim back. Okay. It covered a total of 60 meters in 30 seconds. So we are assuming the duck swim in a straight line, right? Yes or no? That's the important thing that we need to make, right? This assumption. If the duck keeps swimming like that, can we solve this problem? No. No, right? So this is a very big important assumption that we need to make, right? The duck swims in a straight line, right? Huh? No need. I'm just trying to explain to you. So, don't assume. Then you solve this question for me. Okay, so this is important. I mean, questions like this, logically, we need to make important assumptions like this. Okay, it's swimming in a straight line. Alright? Okay, it covered a total of 60 meters in 30 seconds. So where is 60 meters? Is from here to here and back, right? So if that's the case, now from here to here, from one end of the pond to another end of the pond, what's the distance, Colin Chi? Hey, seriously? Colin Chi? Today is not April Fool's, okay? Stop it. Keep quiet. Let him have some peace to think about what's the correct answer. What's that to be confused? The distance from one end of the pond to another, what's the distance? Don't complicate a very simple question, okay? Because sometimes you think too complicated. Hey, children, you're giving him too much pressure. He cannot think, you know. You're giving him too much pressure. Okay, keep quiet. Please. Okay, Lauren, tell me what's the distance from one end to another end? What's the answer? 30 meters, right? Logically, right? Back and forth is 60. One end to another end will be 30 meters, right? Okay. So, second assumption we're going to make is that it's swimming at a constant speed. Okay? No. Yeah, let's say we is traveling at the same average speed throughout. Okay, let's say it's traveling at this constant average speed throughout. Right? Very simple question, Colin Chi. How long does it take to swim from one end to another end? One end to another end, assuming it's like constant average speed. You sure? No lah, of course you're right. 30 seconds divided by 2. Okay? So that's assuming. But in this question, is it true 15 seconds? No, right? Because they say, okay, First part 10 seconds, right? Second part must be how many seconds? 20 seconds, right? So we want to find 20 seconds. So you want to find the average speed. Wait. Because Ernest is like really interested in solving this question. Wait. Hey, better keep your mouth shut, y'all. Now, Ernest, what is the total distance? Huh? Total distance is not 60 meters, meh? What, my game? Who's the one? Hey, keep quiet. Do you hear what he said or not? Do you understand what is he saying? Then Ernest, repeat to Beyond, because Beyond needs to hear this part urgently. Do you agree with him? Because why? The question say what? And then? Okay, but then, so Beyond, if I want to do total distance divided by total time, can you tell me what's the total distance? Then total time? 15 Not 15 seconds, man, average speed. So do you all agree with him? Because we are finding average speed for the second part of the journey. So total distance for the second part of the journey divided by total time for the second part of the journey. Do you understand? Okay, so don't make careless mistakes like this. So it's 30 meters divided by 20 seconds, which equals to 1.5 meter per second, right? Yeah. If there's no problem, let's move on to the next question. I'll try my best. Okay, next question. A motorist traveled 2/5 of his journey in 4/5 hour. So we have this journey. Okay, so this is entire journey. Now what I have is I need to cut a journey into 5 parts. 1, 2, 3, 4, 5. So for 2/5 of his journey, the time taken is actually 4/5 hour. He then traveled the remaining 84 km. So that means this is the remaining, right? In actually 1 1/5 hour. Correct? Yes? Yeah. Is it clear enough, the diagram? Now, first part, part A. Find the total time taken for the whole journey. Isabel, what's the working? Can't hear you, too soft. Distance divided by? For what? Do I even have speed? Then, okay, let's say she did not say that. Give her the benefit of the doubt. Can you speak loudly so that all of us can hear? How do I find the total time for the whole journey? Do you all agree with her? Because this is the total time for the whole journey, right? So it's 2 hours. Who does not agree with her? Who does not agree? Quite easy, right? Because I already draw up neatly for you the time for the first half and the time for the second part of the journey. Okay, so it's 2 hours. Now we want to find the average speed for the whole journey. Average speed. To find average speed, okay, I of course need to have total distance over total time, right? But what is it that we have right now, Colin Chi? Sorry, say again, the last step. No, just continue from the part that you were saying that I asked, what are you talking about?
Okay, so I can take 84 times 5 over 3.
84 times 5 over 3, what does that mean? 84 times 5 divided by 3 give me the total distance. 84 times 5 divided by 3. Okay, never mind, let's wait. Since we know that here is actually 1 unit, right? 3 units equals to 84 km. 1 unit equals how much, Colin G? You don't need to use a calculator for this, right? Now, Jack, tell me what's the total distance in terms of units. Jing Kai, tell me what's the total distance. $140 km. Clarence, tell me how did you get the answer? He took 28 multiplied by 5 to get 140 km. I know. Clarence, better show me this step. This is my last warning to you. Okay? You give me one more 5u equals to 140 without you showing me an intermediate step, you'll copy out the whole worksheet. Okay, so we have the total distance, right? Yes or no? Which is 140 km, but that's not the final answer because we need to find the average speed, right? Alright? So, Lauren, tell me what's the last step. $140 km. So remember, write down your formula. Average speed equals to total distance divided by total time. Okay. And that will give us 140 km divided by 2 hours, which is 70 km per hour. So first answer is 2 hours, the second one is 70 km per hour. Next. Okay, Ron and Jake started walking at constant speed from the same spot in opposite direction along a straight boardwalk. Okay, you know what's a boardwalk, right? Yeah. You know the one they have it as, you know, if you want to cross over to Sentosa, there's this boardwalk, wooden platform. Yeah, it's just a wooden platform, but okay. Right. Yeah, the travelators at the Sentosa boardwalk is most of the time is under repair. I don't know why. Yeah. So I'm going to draw it out for you. This is the straight boardwalk. I have 2 persons, Ron and Jake. Okay, Ron, Jake. They are walking in opposite directions. Okay. After they have walked for 30 minutes, they were 4 km apart. So Ron is here, and then Jake is here. So their distance is actually 4 km apart. We know that Ron is actually walking at 3.5 km per hour. Correct? And he actually walked for 30 minutes. So the time here, in terms of hours, Adelaide, half hour. So if the time here is half hour, what is the distance that's actually walked by Ron? Sky? Tell me your working. Half times 3.5, right? It's because it's actually speed multiplied by time. Okay, speed of Ron multiplied by time taken by Ron. Okay, speed is actually 3.5 km per hour, and time is half hour, which is 1.75 km. So we know that the distance traveled from here to here is 1.75 km. This is Ron. Now, what about the distance walked by Jake? Kaden. How do you get 2.25? 4 minus 1.75, right? 4 km minus 1.75 km, and you get 2.25 km. Now, they want to find Jake's speed, right? Correct? But how long has Jake been walking, Colin Chi?
30 minutes.
Which is, in terms of hour, half hour, right? So, in order to do the last step, Jing Jie, tell me how to find the last step. Distance divided by time taken by Jake, right? So what's the distance? 2.25 km. What's the speed? Time taken by Jake?
30 minutes. Half hour.
Half hour, right? Danish, tell me the answer.
4.5 km slash
Okay, 4.5 km per hour. Don't tell me slash h. So it's 4.5 km per hour. Okay, next question. Okay, what do you find most challenging about the topic on speed? You may copy a problem that you could not solve and point out what you do not understand about the problem. The most challenging about this topic, I feel, is listening to some ridiculous answers. No. Let's leave this blank, okay? Not worth doing. Huh? What do you mean you can only solve part A? Oh, okay. Anyway, let's skip that part. I don't think it's very important. The PSL is not going to say, they won't give you a question 17 and ask you, what's the most challenging you find about this paper? Okay, right? And then after that, copy out the question and solve it. They will not ask you to do something like that for question 17. Alright? No, if you cannot solve one question, that means you cannot solve. You're double penalizing yourself. Yeah. Okay, let's look at put on your thinking cap. Garden City and Fountain City are 180 km apart. So I've got two cities. One of them is Garden City, the other one is Fountain City. Okay? They are 180 km apart. Xavier departed from Garden City, Xavier, and actually Yara departed from Fountain City. Okay? Oh, sorry. Got it wrong because I haven't finished the whole question. Yeah, so sorry. Let me erase the whole thing. Okay, I actually I didn't finish the whole question. I started drawing, so let me redraw it again. Actually, there's actually three cities. One is Space City, one is Fountain City, and one is Garden City. Okay, I know that Xavier departed from here, Yara departed from here, and they are all going towards Space City, right? Why is it that I know that I should put Xavier here and not here? That means how do I know that I need to put Garden City here and not here? Is because, right, The question say that Xavier need to catch up with Yara, correct?
Yeah.
That means, in other words, Yara is closer to Space City. Okay, that's the main thing. That's why I know I should draw my Yara and my Fountain City in front of Xavier and his Garden City. Correct? Okay, now, another thing is, we need to, there's another assumption is that these three cities are on a straight line. Okay? Right? Because if it's not on a straight line, how can Xavier overtake Yara, right? If both of them they are coming from opposite sides, if Space City is in the center, there's no way Xavier is going to overtake Yara, right? Understand or not?
Unless you go
So there's a reason why I draw it this way. Okay, there's some logic behind it. Space City cannot be in the center. Do you all understand why? Okay, or else there's no overtaking. Now, Xavier actually traveled at a constant speed of 80 km per hour. And Yara traveled at a constant speed of 60 km per hour. Another thing that makes sense here is that Xavier must definitely travel at a faster speed, correct? If Yara is 60 km per hour and Xavier is 50 km per hour, will we be able to solve the question? No, right, because there will never be any overtaking. Correct? So Xavier, since he's behind, he must be running or moving faster. Yes? So all this must fall in place nicely, the logic involved. How long did it take Xavier to actually catch up with Yara? So, here, this is, I think, is it clear? So you all know, you saw where the 180 km is? Okay, it's between Garden and Fountain City. Okay, now we know, from this diagram, right, we know that Xavier need to catch up on how many kilometers, Caden? Repeat my question. You can repeat my question, I give it to you because maybe this is a brand new topic. So, not to be unfair to you, just repeat the question. Okay, good. Okay, now imagine, okay, two person running, Jing Kai and Caden. Okay, Jing Kai is in front of Caden by 180 meters. Okay, both of them are running. Caden, how much do you need to do to catch up with Jing Kai? You need to catch up on how many meters? 180 meters, right? Correct or wrong? Since Jing Kai is 180 meters ahead, okay, what Caden need to do is he need to catch up on these 180 meters so that they will be on the same, at the same point, right? Likewise here, Yara is in front, Xavier is behind. Xavier need to catch up on 180 km. And he's able to do that. Why? Because he's moving faster. True? Think about it. Now, at the start, they are 180 km apart. 1 hour later, 1 hour later after the start, okay, how far apart will they be? Colin Chi. No need to use calculator. This is simple logic one. I don't ask you those very tough questions. I say a question again so that I may change another person to answer anytime. Huh? 160 what? Do you all agree with him or not? At the start, the two person is 180 km. Okay, 1 hour later, the distance between them become 160 km. Because every hour what? Do you all hear what he said or not? Do you all hear what Colin Chi said? Okay, never mind. Bjorn, repeat what Colin Chi said since you said you heard. You said you heard what he said. You shake your head. Don't give me this integrity issue, okay? I'm very certain you shake your head. Repeat what is this explanation. Don't give me this kind of lies, integrity issue. You shake your head. Yes, I heard. Better be truthful about it. He did not give this explanation, yes or no, Colin G? Okay. I ask again, who did not hear Colin Chi's explanation? Better be honest. Colin Chi, stand up, repeat the explanation to them. I think he did not hear you. Turn and face him and tell in his face. Why is that so? Explain his statement. Do you understand why? Because Xavier travels 80 km in 1 hour, Yara only travels 60. So every 1 hour, Xavier will catch up by 20 km, yes or no? Yes. But altogether, he need to catch up a total of, what's the distance? 180 km, right? Okay, so if you need to catch up 180 km, how many hours do you think that he need? Lauren? Tell me the working. 180 divided by 20. Do you all agree with her? Yes. So I'm going to summarize the working. Please pay attention. First, we need to know the difference in speed, which is 80 km per hour minus 60 km per hour. So we know that every hour he will be able to catch up 20 km, right? Yep. Next, since I want to know the time taken, time equals to distance divided by speed. The distance to catch up is 180 km. The speed is actually 20 km per hour. So altogether we need 9 hours. Anyone rushing for tuition? What time? You? You? Time. Huh? Okay, we'll stop here for today then.